Uh, Welcome to an immersive dive into the dynamic universe of Flutter, where innovation meets seamless cross-platform development. Today, we are going to unravel the power of Flutter in crafting stunning user interfaces and streamlining your app development experience. Let's embark on this exciting exploration together. This is the overview. We are going to have an overview of Flutter. Next, we are going to look after Flutter's was other frameworks. Then we are going to talk about Dart programming language. In the next, we are going to talk about Flutter architecture. Then building UI with widgets. Then state management in Flutter and hot reload feature. What is Flutter? Flutter is an open source UI software development toolkit. It was created by Google and it is used for building natively compiled applications for mobile, web, and desktop from a single code base. This Flutter was introduced by Google in 2017 and it is designed for crafting high quality native interfaces on iOS and Android. Then it enables the development of cross-platform application with a single code base, and at the same time, it employs the Dart programming language for building applications. This is the logo of the Flutter, and this is the open interface of Flutter. Um, uh, why we are going to use Flutter? Uh, it has the feature of fast development and hot reload and cross-platform development and single code base for um, iOS and Android. Flutter allows developers to build applications for multiple platforms such as iOS and Android using a single code base. Um, it helps developers can write and maintain one code base for both iOS and platform, reducing development effort and increasing code consistency. And also help fast development and hot reload by Flutter facilitates the rapid development through its hot reload feature, enabling developers to instantly view changes made to the code without restarting the entire application. Let's talk about Flutter's other frameworks. Um, Flutter and React Native both empower developers to create cross-platform application, allowing them to write code that can run on both iOS and Android. However, Flutter utilizes Dart as its programming language, offering a unique syntax and set of features, while React Native relies on JavaScript, a language widely known and used in web development. The choice between Dart and JavaScript depends on developer preference and the project. Um, Xamarin supports C Sharp and .NET for building cross-platform functions. It presents a familiar environment for developers with experience in these technologies. In contrast, Flutter uses Dart as its programming language. One notable advantage of Flutter is its hot reload feature, enabling developers to quickly see the impact of code changes in real time, potentially leading to a faster development cycle compared to Xamarin and the native script. Flutter compiles to native code, potentially providing better performance by leveraging the native capabilities of the target platforms. On the other hand, native script relies on JavaScript and TypeScript for development, making it accessible to a broader audience of web developers. The choice between Flutter and native script often involves a trade off between potential performance benefits and developer familiarity with the specific programming language. Uh, Key points here is that Flutter provides a unique combination of a single code base, high performance, and a reactive framework. Um, Consideration of language, performance, and development experience can influence the choice between these frameworks. Let's talk about Dart programming language. Um, Dart is a powerful object oriented and class based programming language developed by Google, introduced in 2011 with a primary focus on building a scalable web and mobile applications. It design emphasizes ease of use and productivity for developers, offering a familiar syntax for those accustomed to object oriented programming paradigms. Dart's versatility makes it well suited for crafting high performance applications, and its association with the Flutter framework reinforces its role in creating cross platform, natively compiled interfaces for both web and mobile platforms. The other one is we are going to talk about key features in Dart programming language. First one is garbage collection, asynchronous programming, strong typing, object oriented. Let's talk about object oriented. Dart follows an object oriented programming paradigm, making it suitable for structuring applications. Uh, the garbage collection feature is automatic memory management through garbage collection, simplifying memory allocation and deallocation. Another feature is that this strong typing one, Dart employs that static typing, providing improved code analysis and catching errors during development. And the other feature is the Dart supports this crucial for developing responsive and performant applications. Uh, Dart was chosen for Flutter for its reactive programming model and user-friendly syntax. Flutter's hot reload leverage, Dart capabilities provide instant updates during development, enhancing developers' experiences. This is why we use Dart for Flutter. Let's talk about Flutter architectures. Um, Flutter's architecture involves several key concepts that work together to create and render user interfaces efficiently. Uh, there are four Flutter architectures. One is high-level architecture, widget tree, and elementary and rendering pipeline. The first one is high-level architecture. The one thing that you have to know is in Flutter, everything is a widget. Are the building blocks of the user interface. This represents everything from a simple button to the entire application. There are two main types of widgets. One is stateful widgets and the other one is stateless. Um, In this framework, Flutter provides a rich framework of pre-designed widgets and tools to create complex UIs. Flutter follows a layered architecture designed for building responsive and scalable applications. High-level architecture involves a combination of framework, engine, and plugins. Let's talk about widget tree. Widget tree structure is the widget hierarchical structure of widgets that represents the UI of the application. It starts from the root widget and branches out into various nested widgets. Each widget in the tree corresponds to a part of the user interface. The widget, let's talk about elementary and rendering pipelines. Element are Elements are an internal representation of widgets and are part of the elementary. Elements are mutable and correspond to instance of widgets in the widget tree. They maintain the state of and life cycle of widgets during rendering purposes. The widget tree is translated into an element tree representing the actual rendered elements. Uh, Render objects in Flutter are the rendering pipeline involves the use of render objects to describe the layout and appearance of widgets. Render objects are responsible for rendering visual elements on screen. Um, the pipeline includes layouts, paints, and composite faces. Let's talk about building UI with widgets. In Flutter, everything is a widget. Widgets are the building blocks of the user interface. Represents everything from a simple button to the entire application. There are two main types of widgets. One is stateful and the other one is stateless. Um, Stateless widgets are the elements that don't change over time. It is defined by their configuration and immutable. uh, Stateful widgets are the dynamic elements that can change over time. They have a mutable state and it allows updates. There are commonly used widgets. One is text widget. It displays textual information. Image widgets loads and displays images. Container widgets. It's a box model for layout and styling. Row and column widgets. It arranges widgets horizontally and vertically. Uh, Stack widgets. They are the overlapping widgets. List view widgets. It displays a scrolling list of widgets. App bar widget. It is a material design app bar. And gesture detector widget. It handles user gestures like taps and swipes. Let's talk about state management in Flutter. Uh, why state management is crucial? State represents the data that can change over time in application. Effective state management ensures a responsive and dynamic user interface. Let's talk about state management approaches in Flutter. There are four approaches. First one is local state, second one is provider package, third one is inherited widget, and fourth one is block, which means business logic component. For the first one, the local state, it is a state managed within a widget using a set stage. In provider package, it is the external package for managing state. Inherited widget is sharing state across widgets in the widget tree. It's useful for small to medium sized applications, and the business logic component is a design pattern for managing state and handling business logics. It offers a separation of concerns and scalabilities. Let's talk about choosing the right state management approach. Uh, there are four factors that we should be concerned about when we are choosing the right state management approach. The first one is project size and the complexity. Second one is developer familiarity and team expertise. Third one is performance consideration. Fourth one is scalability requirements. Uh, Here are some best practices we can use to when we are choosing the best state management practice. We have to consider using a combination of state management approaches based on specific needs, and we have to keep business logic separate from the UI layer. Let's talk about hot reload feature. One of the Flutter standout features is hot reload, which is enable developers to see the immediate impact of code changes in the running app without restarting it. This speeds up the development and debugging processes. uh, this is how it works. Developers make changes to the code. Instead of restarting the entire application, only the modified code is injected into the running Dart virtual machine, and the UI is updated in real time, reflecting the change immediately. Benefits for the developers, it faster development because changes are reflected instantly, significantly reducing the time required for testing and development. The second one is enhanced productivity. Developers can experiment with different UI elements and features quickly, leading to more creative and efficient development. Real-time debugging. Debugging becomes more efficient as developers can see the impact of code changes immediately. And it's the seamless collaboration. Team collaboration is smoother with developers able to share their progress rapidly during development sessions. And the other one is the improved user experience testing. This allows developers to observe and fine tune the user experience in real time. Um, in conclusion, as we navigate the dynamic landscape of Flutter, let's embrace the boundless possibilities it offers for creating a seamless, innovative user experience across diverse platforms. Here's putting the future of app development with Flutter's versatility and efficiency. Thank you so much for being here with this presentation.